a scientific notation problem. So as I look up here on the board and I see review notes, measurements, and calculations day 2, we are going to start out by working this first problem. But let's first go over the our I can statements. So these should be pretty similar to what we just discussed with Quinn and Logan and Natalie. Okay? So I can convert standard numbers into scientific notation. I can convert scientific notation into standard numbers. So I can do it one way and then flip it back the other way if so needed. Okay? I can convert using the metric system. As I said, we're familiar with the King Henry died by drinking chocolate milk. We're going to go above and below that normal comfort zone. All right? So, the very first thing we are going to do is we're going to convert the following numbers into scientific notation. So as I look at this fellow right here, I see my decimal. And I am going to be moving my decimal into a number that is between 1 and 9. So I am going to move my decimal to right here in between the 2 and the 3. So as I do so, I'm jumping my decimal 1 spot, 2 spots, 3 spots, 4 spots, 5 spots. Okay? If I move that 5 spots into the right-hand direction, I'm going into the negative direction. So my answer is going to be 2.3 times 10 to the negative 5th. My second example, 101,000. I need to put that number into scientific notation. Now, first of all, my decimal isn't here, is it? Okay, my decimal isn't here. Why would I not have a decimal here? Well, probably because these zeros right here are going to be placeholders that you'll see after today. Because we're going to talk about some sig figs later on today. So you'll see that those zeros are placeholders. If I would put a decimal where that needs to be, right here, that would say that those are all significant, which wouldn't be the case. All right? So I know that my decimal point right there is after my place holding zeros. I am moving my decimal to a number that is between 1 and 10, so I'm going to move my decimal right here. So when I do so, I jump at 1, 2, 3, 4, 5. All right? So I've jumped that 5 to the left, so I'm getting positive numbers. So now my new number is 1.01 times 10 to the 5th. Now, do you notice that I did not include those placeholders? I did not include the placeholders because those are not significant. So I only have the 3 digits that are significant included. Convert the following numbers into standard notation. Here I have a scientific notation. I have 2.30 times 10 to the 4th. Now, I can see, and you will like I said, you'll learn this today, that I have 1. Oh, I guess I'm going to put that down right. I have 1. I have 2, I have 3 significant digits in this one. I am going to move this that way. 1, 2, 3, 4. So I need to have a couple more placeholders. So I have 2, 3, 0, 0, 0 as my number. But the problem here, ladies and gentlemen, is that when I get to know sig figs, I'm going to have to put a bar right here to show that that 0 is significant, but the other 2 behind it are not. Because in this specific one, I have 3 sig figs. Okay? So when I get this number here, to be most correct, I need to put that bar over that 0. My next one, 1.901 times 10 to the negative 7th. When I see that negative 7, I know that that's a really small number. Okay? I know that's a really small number. So what I'm going to do is I am going to jump my decimal 7 spots to the left. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6. My number is going to be a 0 with 6 zeros and then a 1, 901. So that is the actual number that I just wrote there. We okay with scientific notation? Give me a thumbs up. Let me see. All right. Hopefully that is a review that we've done this in a math class somewhere, like I said before. Now let's get into some things that you probably haven't done. Okay? So wherever you've got your metric conversion, wherever you got your metric conversion chart, get that baby out and find that, because we're going to use it. This one is not so bad because we're familiar with this one. This is still a King Henry died by drinking chocolate milk, because I'm going from millimeters to kilometers. Now, when I switch to this side, when I switch to this slide, this is just simply a different version of what you should have in your notes. And what I'm doing for this particular one is I'm right here at milli, and I want to go up here to kilo. Now, the way you've been taught to do it is to jump and bounce probably from one to the other. I'm going to show you how to do it by reading this 10 to the minus third and that 10 to the third. Now, I have 3. 1, 2, 3 to get to 0. 1, 2, 3 to get to the plus 3. So that tells me that I need to make 6 jumps. 3 to get to 0, 3 to get to plus 3. So I need to make 6 jumps. And when I am jumping up, okay, I'm moving it to the left. When I jump down, I'm moving it to the right. So what I need to do, I come back to, well, you dirty little thing. I come back to here, excuse me, and I need to jump 6 to the left. My decimal's right here. 1, 2, 3, 4, 5, 6. So this number that many millimeters is equal to 8.4574 kilometers. We okay with that one? Like I said, that one was a King Henry died by drinking chocolate milk one. Man, you're killing me here. All right. Now here we go. Here we're getting into some that we might not have done yet. All right. So what I need to do for this one is I've got hectometers and I'm going to gigameters. Hectometers to gigameters. So here is my hecto. Here is my giga, right? So by looking at my exponents, I see a 10 to the 9th and I see a 10 to the 2nd. How many jumps do I need to get from 2 to 9? 7 jumps, right? 7 jumps. What way am I going to jump it? To the left. So when I come back here, okay, when I come back here, I'm going to jump this 7 to the left. So my new number is 0.6735 capital G M. Because giga is the capital G. We all right with that one? Now we have one in which I am jumping from millimeters to micrometers. Millimeters to micrometers. So, here's millimeters. Here's micrometers. And notice that micro is abbreviated like that. That little funky looking U with the long tail. All right. Now, here's a part that I want you to make sure you're aware of. Okay? That even though they're right beside each other, is it one jump? It is not, because I'm reading the exponents, right? I'm reading the exponents. So how many jumps is it? How many jumps am I dealing with here? 3. Okay? Which direction am I jumping them? To the right. So as I come back here and say I'm jumping 3 to the right. 1, 2, 3. My new number now is 0.645 micrometers. We thumbs up with that one? We're okay reading the chart, even though they're right beside the 3 jumps? Let's go one here. Nanometers to decimeters. Nanometers to decimeters. There's nano. There's decimeters. So how many jumps am I making? How many jumps am I making? Anyone, anyone, anyone? 8. I'm making 8 jumps. What direction am I jumping it? To the left, right? So 8 jumps to the left. One, 2, 3, 4, 5, 6, 7, 8. So my conversion number is 0.01011 decimeters. Now, I'm going to do one more. I'm going to do one more just so that we have, how do I want to say it? Just so we get one more play here. Or we don't even need to work one. Let's just talk about it once again. Okay? Excuse me. When I'm doing something like going from a negative value, okay? Here's micro, and let's say I want to go to hecto. Okay? I know that I'm going up, so I'm jumping at which direction? To the left. I'm jumping it to the left. Now, the key point here is I have 6 jumps to get to 0. I have 6 jumps to get to 0, and then to get back to here, I have 2 more. Okay? So that is 8 total jumps that I'm making to the left. I want to make sure we have that. Okay? That we got to go 6 to get to the 0, and then another couple too. Okay, so that seems to be where I see folks having the most issues when we're dealing with these metric conversions. Okay? When we're dealing with these metric conversions.